A patient who is diabetic receives 100 micrograms of insulin. The graph shows the amount of insulin in micrograms remaining in his bloodstream over time in minutes. Scientists have found that the amount of insulin in a patient's body changes exponentially. How can you check if the graph supports the scientists' claim? You can see that the data form a smooth curve, which seems to be an exponential shape. If the insulin decays exponentially, that means that after each minute, the same fraction of insulin will remain. So one way to check if this prediction matches the data is to see what fraction of insulin remains after the first minute, then after the second minute, and so on. If these fractions are the same, then the graph supports the scientists' claim. Dividing consecutive points y values will help us to see if the ratio remains constant. All of the ratios simplify to 9/10, which represents the constant ratio. This means that the graph is exponential. Describe how you would find how many micrograms of insulin remain in his bloodstream after m minutes. To determine how many micrograms of insulin remain after m minutes, it's best to use the graph to write an equation. Because this is an exponential function, we can use the form y equals a times b to the x. From this graph, you can see that the y-intercept is 100. This is the a value in the equation. The b value is the constant ratio. Since this scenario is actually exponential decay, we expect b to be less than 1. We found the constant ratio earlier when we divided consecutive points y values. The constant ratio 9/10. This is our b value. The pieces can be assembled into an exponential equation of the situation. Now we have an equation to represent the amount of insulin y left after x minutes.